Hello, everyone. Welcome to the Better Buildings webinar series. Let's get started, and welcome to today's Better Buildings webinar, dedicated to bringing you the latest actionable insights from leading industry experts. Better Buildings webinars are a chance to explore the topics, technologies, and trends that affect your organizations, as well as efforts to accelerate decarbonization and energy efficiency adoption. As you heard, this is being recorded. So if you display your face, talk during this webinar, you will consent to being recorded. Today's webinar is called From Smart to Smarter, Advances in Industrial Control Systems Improve Efficiency. Before we dive in, there are a few housekeeping points I'd like to cover. Please note, I got ahead of myself before, didn't I? Please note today's webinar will be recorded and archived on the Better Building Solutions Center. We will follow up when today's recording and slides are made available. Next, attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send them a message in the Q&A box located on the bottom of your Zoom panel, and our tech support team will be in touch with you. Thank you. I think we can go to the next slide. I am not seeing the slides advance on my end.
Sorry, Ethan, we'll fix that in one moment.
Do I need to repeat any of what I just said?
No, you're good. We'll just work on, there's some screen technical difficulties. So we'll fix that on our end as soon as we can.
Okay, so I'll go ahead and move forward. My name is Ethan Rogers. I'm a technology manager with the Industrial Efficiency and Decarbonization Office. I lead a couple of different programs related to industrial energy efficiency and workforce development. They are adjacent to and supportive of the Better Buildings, Better Plants, and Better Climate Change, Better Climate Challenge programs. You may have heard of the 50,001 Ready program. We have several other programs. But happy to be here today moderating this session, this webinar. So today we'll be using an interactive platform for the question and answer and for the polling. Actually, I need to first talk about the agenda. First, we'll cover the introduction overview. Then we'll do some polling, and then we'll get into our speaker presentations. And then we'll close with some question and answer session. For the polling and the Q&A, we'll be using an interactive platform called Slido. So please go to slido.com on your mobile device or by opening a new window in your internet browser. Today's code is #DOE. If you'd like to ask our panelists questions, please submit them anytime throughout the presentation. We will be answering your questions near the end of the webinar. You can select the thumbs up icon for questions that you like, which will result in the most popular questions moving to the top of the queue. So let's go ahead and get into some of our Slido questions. We want to learn more about you. So we'll start off with a few polls. Please join us over at Slido to respond to the following questions. If you have any issues, please message our tech support team by using the Zoom Q&A function. So, okay. Okay.
Sorry, Ethan. Again, we're just having some screen sharing technical difficulties, but we'll get over to Slido in a moment.
Okay. Giving people a little extra time to log into Slido, I suppose. Here we go. Have you ever used artificial intelligence in your facility? We're really curious to see where people are on this adoption curve. It's really interesting to us. You hear about it so much in the news and everything, and we're pretty sure eventually it's going to become ubiquitous. But right now, it seems like most people are not using it, at least at work. So it seems like our numbers are starting to stabilize. Maybe give it a few more seconds. And then, okay, I think we can go on to our next question. Seems like about two-thirds of the folks have used artificial intelligence in some fashion at work. Um, have you used any of the following key components of smart manufacturing in your facility? And when you think about smart manufacturing, there's a lot of different components to it. People come into it incrementally. I suspect many of you have some type of dashboards that you use, maybe some green light, yellow light, red light type of indicators, or some type of dials that tell you if something is working. But I'm also kind of interested in how many of you are collecting data, historical data, that you can then use to do some modeling, specifically a digital twin. This obviously isn't a comprehensive list of the technologies that make up smart manufacturing, but I think it kind of speaks to maybe the progression people might have as they get into this field. You start with kind of real-time information on a dashboard, and then you start collecting information, and then you start manipulating it. I'm really glad to see the data historians. Two-thirds of the people have data historians. That's excellent. That's actually a lot more than I thought it would be. So that's to me kind of a pillar of being able to use. I mean, obviously you have to have that data if you're going to do some predictive modeling of what's going to happen. Okay, we can go on to the next question. What percent of your utility bill would you guess is compressed air usage? So good old compressed air. And I guess you can type in a number there. We'll see how this works out. But I remember a couple of decades ago when our office started studying compressed air, we started studying motor usage in manufacturing, and we found out that very often one of the biggest induction motors in plants was the one driving the air compressors. You know, a lot of factories have a lot of 5, 10, 25 horsepower motors, but they would have like 100 horsepower or bigger driving their air compressor. And so obviously it could be a big consumer of energy. So, okay, so we're not seen as between 1 to 30%. Okay, cool. And do we have one more question to remember? Or is that it? Yeah. Uh, what percent of utility is wasted on inefficient compressed air operations? So, how much of your compressed air do you think is not producing work for you, is wasted? And we're talking once you've made the compressed air, not necessarily the efficiency of the air compressor, but when you put that into distribution, how much do you think is not producing useful work? Yeah, we're seeing some pretty high numbers there. Excellent. Yep. It's all over the map, isn't it? Well, then you're at the right webinar because we're going to have a great presentation on how to optimize your compressed air system today. Okay, we can go on to the next one. All right. So we've got a great lineup today. I've worked with some of these folks in my programs and just people with great resumes and experiences dealing with energy efficiency. Our first speaker will be Ten Masoni. He is a senior energy and sustainability specialist as part of 3M's corporate sustainability team. He's dedicated to improving 3M's decarbonization journey with a certified energy manager, certified measurement and verification professional, renewable energy professional, and ISO 50001 lead auditor. Uh, AEE certifications. Our second speaker will be Corey Anderson as a utilities supervisor for 3M Hutchinson, Minnesota manufacturing facility. Our third speaker will be James Farley. He is an advanced manufacturing engineer at 3M's Valley, Nebraska manufacturing facility, specializing in data engineering and analytics. In the last 3 years, James has supported the site's local energy team in projects to help reduce the facility's energy usage. Our fourth speaker is Kit Yang Shen. She is an energy engineer at Niagara Bottling, focused on energy system analysis and modeling, energy auditing and efficiency assessments, and cost-benefit analysis. And our last speaker, Robert Miner, is a program engineer too at Niagara Bottling with experience in mechanical engineering, 6 years of experience in bottling, and 20 plus years of experience in HVAC and compressed air. Thank you all for being on our webinar today. We're really looking forward to hearing your presentation. And with that, I will hand it off to Tanmay to kick us off.
Thank you so much, Ethan. Really appreciate it. Hopefully you can hear me. Okay, perfect. Yeah. So hi everyone, Tanmay here. Thanks for the introduction again. Next slide, please. Perfect. So before we jump right into the projects example that we have from 3M facilities, Hutchinson and Valley, I just wanted to set the stage for the audience here around the way that we are looking into the overall decarbonization strategy at 3M. There are whole different sets of instruments we are evaluating right now, which reduces our scope 1 and 2 emissions. However, again, just to set the stage here, 3M is an industrial conglomerate producing more than 10,000 plus products. And you might have always mostly heard about products like 3M masking tapes, the N95 masks, the sticky notes, the Scotch brand, right? So they say that you're never more than 10 to 15 feet away from a 3M product. So that's a little bit about 3M for you. Speaking about sustainability, we have three main high-level targets: science for circular, science for community, and science for climate. So next slide, please. That's where I'm going to focus more on the science for climate piece. And that should be enough for the goal setting in terms of how we are thinking about climate, what kind of targets we have set up, and what kind of strategy we are implementing, and how energy efficiency fits right within that, right? So as you can see from the slide here, in terms of emissions, we have the goal to reduce the emissions, both scope 1 and 2 market-based, by 50% by 2030, 80% by 2040, and eventually reach the carbon neutrality into our operations by 2050. So that's the very high-level overarching goal from the emissions perspective. When it comes to the renewable energy, it's basically to increase the overall renewable energy to 50% by 2025 and 100% by 2050. So we are evaluating different sites at 3M globally to see what kind of instruments we have available and how can we achieve those, right? But before we jump right into the project here, if we can move on to the next slide. This is the high-level strategy that I talked about. So in order for us to reduce our carbon reduction into the energy usage for our own facilities, we are thinking to reduce our overall emissions by three aspects. Number one is renewable energy. How can we increase the portfolio of renewable energy into our own operations? That's where majority of our energy is consumed, clearly. So when we talk about electricity, that's basically the first column here on the left-hand side. So far, 3M has invested into power purchase agreements, on-site renewables as well, and we continue to do so at other global sites as the feasibility of each instrument evolve, right? So the three different buckets you see here, the grid utility, the 3M owned renewables and PPAs, that remains our strategy right now as we continue to evaluate some of the options too. But majority of our renewable energy portion comes from power purchase agreements that we have set up so far. The right-hand side piece, the energy carbon emissions, that's more to do with the natural gas and how can we tackle the challenge of natural gas reduction in our operations, and 3M being very natural gas heavy when it comes to some of our products requirements from the process perspective. We do have quite a bit of a thermal load, and clearly, of course, to heat the building as well for the space heating requirements too for global locations. We are thinking about doing that by tackling how can we reduce the fossil fuel dependence, right? So some of the examples I'm sure our audience would have heard, like the fuel switching, the feasibility of solar thermal, can we use biofuels, and there has been a lot of talks about green hydrogen and even the RE electrification as well there. So that's basically the right mix, right? And the carbon capture is one of the last ones in a way where if there is no other option within the site level, and for us to reduce the um, amount of disruption at our sites, right? So for us to be continually operating our products and processes the same way, but if we still want to reduce the scope 1 emissions, then carbon capture is something that we are also looking at. And the middle piece is exactly where our speakers from Hutchinson and Valley side is going to focus. That's basically the very important fundamental energy efficiency piece. So 3M has been a long-time leader into providing examples for energy efficiency projects. We also have had a very number of sites certified to ISO 50001. So the culture of energy efficiency has been ingrained into our manufacturing sites at most locations. We call those tier 1 locations. So those are basically our high energy consuming sites. The second piece you see there is the energy monitoring and reporting. Again, more to come from that from Bailey and Hutchinson team. And the last one is how can we improve the energy efficiency into the early design of CapEx projects, right? Because the last thing we want to do from a site perspective is to replace our equipment like for like. So if there are any major CapEx projects already coming up, how can we ensure that not only the energy team is participating into those decisions, but basically it becomes a holistic decision where everyone can consider energy efficiency and give it the same amount of importance as other things. So again, 10,000 feet level, very high level strategy, the way that we are thinking about the overall emission reduction. And next slide, please. Our speakers from Hutchinson and Valley can take over from that. So
Thank you,
I think we
Tim.
already spoke about this one. Yeah, the goal, but yeah, there was one more. Yeah, so this is just to highlight the focus of energy efficiency. So yeah, the next would be Corey. Ethan, over to you.
Okay, thank you so much, Sam. Now we'll hear from Corey Anderson. Thank you. Take it away, Corey.
All right. Hello, everybody. You can go to the next slide. I'm just giving you a high overview of our site. We've been in this area. The plant's been active since 1947. Got roughly 1.5 million square feet of manufacturing space. I believe that is the largest manufacturing site 3M has in North America. You can see we move almost 500,000 shipped and received loads a year. Next slide. Roughly almost 1,400 employees serving 71 communities in the area, 1,600 roughly visitors a year. You can see the majority of our major brands that we make on site listed below. You go next slide. So 3M Hutchinson did an ever active steam trap monitoring project. As Dan May said, Hutchinson is a tier 1 plant and leader, sought the benefits of a monitoring communication system and dashboard aligned with the communication, energy, and operation savings. Ever active is a batteryless and wireless steam trap monitoring and communication using LTE network. It's a cloud-based platform. The system analyzes our alarm traps, anomalies, and early identification, trending, and energy efficiency. Ongoing monitoring identifies early anomalies not identified. And then, get behind one. So currently, our area crafts are performing an annual trap PM. It consists of taking ultrasonic readings across each trap, having their predictive group analyze these readings, recommend repairs, and the crafts need to go back and make the repairs. Roughly annually, we're spending 200 man hours a year at that process. Go next slide. So this is an overview of how the EverActive system and the data flow and protocols work. They have the Ever sensors, the mount on the traps, go to a gateway to an Ever cloud where they analyze that data and they send back a dashboard. We currently have that dashboard in our control room that monitored 24/7 so we can react to any alarms. Next slide. So here's a picture of what the dashboard is in our area. You'll see we've got 1,233 traps on site monitored. Right now, we don't have any alarms. Each user can set up an automated notification system. So our frontline crafts, the guys that make the repairs, get an immediate notification from the dashboard if there's a failure. While the management, we set up a daily summary report. Next slide. This is an overview of the installation of the EverActive process. So they have a thermoelectric generator that you off the heat from the condensate that creates the power. So we don't have any maintenance on the system to go out and change batteries, or we don't have to run power to them. You have the Ever sensor that sends the data to the gateway, and then we monitor the inlet trap temp in and out with the semi-rigid connector. Some of the barriers we had during this implementation is they currently, during implementation, didn't have class 1, Div 1, electric classified UL listed devices. We have many areas in our manufacturing facility that are rated class 1, Div 1. So we worked with EverActive, weekly updates, communications to implement team, track this and monitor. They've got it approved, and that's how we completed the project in this area. Next slide. So this is part of the dashboard that shows as we get an alarm, you'll see that the resolve trap tag comes up. It'll give us our information where this trap is in the plant. It'll use the orifice side, the pressure to calculate the steam loss and then the savings from the rapid repair. As part of this implementation, we supplied the crafts with a notebook for the added capability to track, resolve, and update alarms on the production floor. This added feature helps in operational efficiency of locating and resolving alarms while updating trap notes, characteristics and conditions of the traps record in the system for future analytics and troubleshooting. Next slide. So this is just a review of our Q3 and Q4 data so far. Again, we monitor 1,233 traps. We've had 9 trap failures. All of them have been resolved. Our average resolution time is 26 hours. So it's continuous monitoring, knowledge building for the plant operators and maintenance, reduced operational costs, elimination of the annual survey, system maintenance, the batterless monitoring, projects scalable and repeatable and being implemented in other 3M plants. In addition to the program installation, this improvement included updating plant drawings, 10-year negotiated fixed monitoring service agreement, quarterly savings reportings, and product support. Again, our response time is less than 26 hours at Hutchinson. The industry average utilizing the EverActive is currently at 2 weeks. Next slide, please. So overall, our environmental savings impact for Q2 and Q3 of this year, we've had a reduction of 874 tons of CO2, which you can see the equivalent to the vehicles driven, the barrels of oil, and the home's annual electrical use are affected. That will be the end of my presentation.
Okay. Thanks, Corey. I'll go ahead and go
Sorry,
into
I had
Valley.
myself on mute. I'm
Oh, okay.
sorry. I was going to say, but yeah, well, thank you so much, Corey. We'll now hear from James Farley.
Thank you. So James Farley, I am a manufacturing engineer at 3M's Valley, Nebraska site. We can go ahead and go to the next slide. So I'll be talking about kind of our journey to improve our energy data on site. Again, this is a manufacturing site. So just how our energy data connects to some of our energy projects and how we were able to verify some of our results. Next slide. So Valley, Nebraska, we make personal safety products. So this is going to be reusable respirators, disposable respirators, things like earmuffs, many more products as well. Not quite the same size as Hutchinson, employs around 500 employees, but of course, many of our processes, could involve heating, have motors, conveyors, compressed air, of course, being in our location, HVAC and winter and summer weather is really important as well for our overall energy usage. Next slide. So I was going to framework some of our projects just on this slide to talk about what we really want to do with our energy data. So we want to make sure that we can make our energy data actionable, just like Hutchinson has done there with a quick response time. The quicker and the less lag and the more automated you can make things, that's really going to help make quicker actions, make better decisions. And the actions we want to do is make and document energy improvements. And in addition to that, verify, audit, and make sure that we have controls for our energy improvements. We want to meet corporate objectives. We were meeting ISO 50001. So that's just the overall kind of framework that I was going to present some of these projects on. So next slide. So talking about our overall energy data at our site, when we were first looking at improving this, we looked at our direct sources, that would be like utility bills and metering. And then it's also important in a manufacturing site to also look at like our manufacturing data. Hey, what are we making? How much of it? Are we spending a lot of labor, machine hours? Are we reporting that? We can correlate some of that information to energy usage as well, in addition to our weather data, data from our historian. So like what our machine is running at, what its settings are, and then also our building management systems. So at a larger facility, we'll have softwares that will pull together all of our lighting, fans, HVAC, and some of those softwares also allow us to get data from them. So next slide. So in these areas, we'd identified and made some improvement for metering and sensoring. Of course, it can be a challenge just to get the right technology, and there'll be a little bit of cost associated with that. But this has really helped us make sure that our energy projects have really good results, and then we can also create better and more real-time correlations. And then the other thing that we added in was weather data, which is simply from the NASA API, and I have some more information on the next slide. So this is something that anyone can do. Is the NASA has something called the Power Project, where basically you can put in your coordinates of where your facility's location is, and it'll spit out what your weather data is, things like average temperatures per day and things like that. So you can take this information and pull it into Excel, Power BI, or different analytics softwares. And that can be really helpful to match with some of your energy projects. We'll go to the next slide. So I'll talk about a couple different projects we've done at Valley. The first one is on an HVAC controls upgrade. Be the next slide. So on our HVAC, we switched to having variable compressor and fan speeds. And this project overall for our site saved us about 3.5% site improvement on energy efficiency. So to verify and to help make sure that we made this change, we were able to match data from our meters So our electrical meters on panels go into our HVAC system. And then we're also able to create a model with the weather data from that NASA API. And then kind of putting those together, we were able to target and verify our improvements. And then the software I used for this was Power BI. I'll talk a little bit more about that next. So just, I guess, first of all, what is Power BI? If you haven't heard of it before, it's a Microsoft software for business intelligence that helps pull together data from multiple different sources. It can do this automatically, which is really nice. It also allows for joining and filtering tables and data analytics. And you can have alerts on different thresholds. So you can set up automated emails and things like that too. Another alternative software is Red Screen for energy data and some basic correlations. But here, what I was doing is matching up weather data and a regression model to our energy usage, and it just allows you to match those up because both these data sets have dates with them. And then you can find the best model which has a good fit. So there's more on the next slide. This was our baseline period for before we had implemented the project. These blue bars are each month, a 95% confidence interval of where we think we would be based on weather data on that this was trained on for those 24 months. And then these yellow dots are where we actually were. So we use more electricity for heating and cooling. So at the beginning of the year for January, February, and then into the summers. And that's what you're seeing on this trend of when we're using more energy. So then the next slide. This is continuing that trend out using the same baseline model. And then the new weather data that we gained from what happened in the last 2-3 years. So as this control system was implemented, we were able to kind of look at our data and send back feedback back to our vendors to make sure that we were fine-tuning this the right way. And this helped us continue to make improvements even after the first year. So the first year we saw a 5% improvement, then a 19%, and then a 28% improvement. Overall, this is equivalent to on pace to 1.5 million pounds of carbon per year. And really, we weren't able to have this visibility or to give that feedback back to the vendors to make the improvement without some sort of model like this. And it really helps that it can be created in an automated way. So it's just ready to go and send back and give feedback to. So on the next slide, we'll talk about another project. So another, just like mentioned earlier, compressed air is a big hitter in manufacturing. You want to do everything you can to reduce your compressed air usage because it's often very inefficient to use compressed air. So we installed a lot of compressed air meters into our processes and have been historizing this data. Overall, I'll talk about this project on some of our machines that resulted in an overall 2% site improvement for us. We were able to match up what the meter says to what the machine says it's doing, and then create some limits to allow our maintenance techs to know when our air usage is high, when a machine is in idle. So basically when we're seeing leaks or we're seeing something in the programming that is allowing a machine to release compressed air when it is idle. So I'll talk more about that in the next slide. So this is just what you get when you first install a sensor, just some graph over time of how much usage CFM you're using per time. We'll go next slide. and put some more context around this. So we have a higher usage when we're at run. It goes down a little bit when we're at idle, and you can kind of see that over time. And this context really helps us establish some baselines and get an idea of where we are. So some of these like white intervals are where I'm taking in like a window of, okay, what is our average usage when we're in an idle state? So we'll go next. So that was our baseline. We were pretty high usage on some of those idle states, but there were some machine improvements that were made in both the programming and the hardware of the machine to make sure that certain parts of the machine were turned off while it was idle, and also to eliminate any extra leaks in the machine itself. And overall, on a lot of these machines, it was a 70% reduction while idle, which is great, but we still got to control it. And we just got to make sure that this is going to be sustainable long term. So on the next slide, we'll talk a little bit about the control plan. We replicated the same process of making this improvement across 15 identical machines. And then what we would do is take those windows of how much air is using in the idle stage, and then we would graph that out. And on an automated way, we can send alerts to our maintenance team to let them know when that idle air usage is high. And this allows us to get a much quicker response to leaks or changes in programming that they can act on to reduce the air usage again and keep it below this threshold really long term. And we've seen a good success in this in the last couple of years. So overall, this was more around 0.8 million pounds of CO2 per year improvement. So that's all I had for Valley.
Thank you, James. That's wonderful. Both the visuals that you provided and Corey provided, and the quick turnaround on resolving these issues is pretty remarkable. Compressed air leaks, steam leaks, to get those taken care of within like a day is pretty remarkable. Now we'll hear from Kit and Cheng and Robert Miner. Welcome, thank you, and I'm going to turn it over to the two of you to start your presentation.
Hey everyone, nice to meet you, and thanks 3M for sharing those projects. They are really good projects. Here for Niagara, this is our project that we're going to be sharing about intelligent air compressor controls. Let's move on to the next slide. This is just a little introduction about our company. We are Niagara Bottling. We are a beverage manufacturer in North America. We have our HQ in Diamond Bar, CA, California, closer to LA side. We are partners with Better Plants program starting earlier this year. We now have 53 plants in North America, and we do have 4 more plants coming up in the next 2 years. On the right-hand side, you can see a map of all of our locations, yellow flags being new locations in 2025, and we have 2 more in 2026, which is in those areas with the green flags here. Next slide, please. We'll bring this to Robert, our program engineer, to talk about this, a little overview about this project.
Thank you, Kit. So, you know, as we all know, compressed air utility is pretty expensive. You know, arguably the most expensive utility cost we have is compressed air. So, you know, leak reduction is a big part of that. And, you know, we thought we could take that leak reduction one step further and control compressors in a dynamic way that would increase the efficiency. So what we did is we tied a lot of sensors back to an AI-based machine learning model that could control our compressors. We have a little over 500 compressors in the US, and we've been running them for, you know, since 1963. So we always thought we were pretty good at staging them properly and making sure the right compressor was running at the right time. Unfortunately, this is a manual process that required an operator to go switch the compressor in a timely manner. And if he didn't get to it, well, then that was an opportunity we lost right there. So doing it with AI has really helped reduce the waste, and it's helped control our compressors in a much more efficient manner. You know, and we did this for simple reasons. The excess waste and the inefficient control costs a lot of money. So you can go to the next slide, please. Our goal here was to eliminate excess pressure that we didn't need, you know, which reduced energy waste. We also optimized our compressor operation. And as a side bonus, we reduced wear and tear on our compressors because we're not running them nearly as hard as we used to. And some of them even get to spend some time down altogether. You can go to the next one. Some of the benefits we found by doing this were proper load sharing. You know, we run multiple types of compressors, and many of our plants have a centrifugal compressor and a reciprocating compressor set up. Centrifugals can be much more efficient if they're used properly. So by being able to support a centrifugal with a reciprocating and do it in a timely or a real-time manner with AI has dramatically reduced our utility cost for compressed air. We're also able to maintain a more stable pressure, so we have less peaks and valleys in our system pressure throughout the day. We also get to monitor equipment health. This also comes with the benefit of monitoring for leaks. The system recognizes when the system is losing air and can alert back to leaks. And it gives it all in real time. We have visual monitoring in real time. We were unable to share that dashboard right now, but hopefully in the future we'll be able to share it. You can go to the next slide, which I think might be Kit's. Yep, I'm going to give it back to Kit for this part.
Yep, for this slide, so these are the 4 major steps, simplified steps of how we implement this project. So we started by logging the baseline for a period of time from your IoT collection, or what you call Internet of Things. We would be using, well, we've used loggers, actual loggers and sensors, and put it onto the machine. And with that being said, we use the raw data and historical data to feed it into the AI model. And with that, machine learning or deep learning has a feature of utilizing the predictive analysis. That way they would be able to use the historical trend, increased trend, upward trend, downward trend, and feed that into the model to dynamically control the system in order to hit the maximum efficiency, especially when you're working with multiple units across. After that, these data will be uploaded into a cloud system and to put it into a graph and visualization for better monitoring. Just like the previous slide that James mentioned, that Power BI is a good tool for creating graphs and all. It would be easier to identify any anomalies or any outliers that you have within your system. That is the 4 major steps that we have implementing these projects. To simplify it, this is the way to do it, but there are a lot of different challenges and steps to do it in the back end of it when it goes to the AI algorithm. Next slide, please. So based on this project, these are the 4 points that we found in terms of energy savings. We were able to draw lesser power, lowering the energy demand and consumption because of the proper load sharing across different units. The results, the actual numbers that we're seeing from this ranges from 8.7% close to 9 to 26%. It comes down to an average of 18.6%. With that being said, compressed air is one of the largest energy users in your utility. So seeing the 18% reduction would amount to a significantly larger amount in terms of your costs and also your energy savings too. We can also now proactively predict repairs and dispatch OEM techs with the real-time monitoring, reduce your wear and tear as well in terms of scheduling your PMs or in terms of handling your sudden failures, your modal failures on your equipment. One of our biggest wins here is that we were able to shut down 2 entire machines in 2 sites, one each, because of the better capacity utilization. Your load sharing ties back to it. And that is a cost avoidance that you would be seeing on your utility bill. Imagine you were able to just entirely not using that machine, and compressor is it's about 30% of your utility bill, and you were able to cut it in half. That is a significant amount of savings there. Next slide, please. Yep. With this, there are a couple hurdles that we face. Like I said, in the baseline data collection, we do need some reliable sensors and loggers in order for you to feed that into the data. So these are the steps that you have to go through in terms of getting your raw historical data. And with that, you would have to calibrate the algorithms to specific plant's condition. In our case, every single plant is operating differently in terms of recipes. So we have different bottles, different sizes, thickness on the bottle. So the AI model would have to detect that using your historical data. And also on your equipment specs, total savings totally dependent on that, because of it's only how much your equipment can do in terms of capabilities, whether if it's a VFD or a non-VFD. When it comes to your MMV process at the end, sub-metering would be very beneficial for you to break down usage at the later comparison stage. You can see your before and after if you're seeing an upward trend or downward trend on your production counts, production data, or your compressed air usage. There are also other factors such as injection molding, blow molding, or production line. In our case, is production lines, because we are a manufacturing facility, that could be driving up the utility bill as well, even if you lower down your compressed air usage. Okay, next slide. I think this is all. Oh, we do have one more. So the next step for this project is that we are looking to scale this project to other facilities, since we have many locations in the US, and there are also a lot of potential for HVAC and chillers operation in terms of sequencing. I think that's it for us from Niagara. Thank you so much.
Thank you, Kit and Robert. That is excellent. And to all of our panelists for their insightful presentations. Now we'll move on to our question and answer session. If you haven't already, please join us at slido.com with the event code #DOE to submit and upvote questions. And I am looking at the questions that have already come in, and I need to get my screens right here. And this, I believe, is for the 3M team, kind of a two-part question. What is the cost per ever active sensor and the expected payback in terms of finding leaks preemptively? And how long have you had the ever active sensors in place, and how many have failed in that time? And are you routinely checking the sensors? So I'll turn it over to whoever wants to take on that question.
Yeah, I can answer that. So the way we went into it holistically at the site, Everactive's business model is more of a subscription based. We chose to purchase all the hardware and just pay for the monitoring. So it's just based off how many sensors you have, and I do not have that off the top of my head. As far as failures, we've been roughly the start of construction to finish 9 to 10 months. We haven't replaced any sensors yet. They do, seasonally wise, they will go offline if you're on say a preheat in the summertime, they'll go offline. But as soon as that preheat starts calling for steam again, it takes about a half hour for that thing to generate power and come back online to the dashboard. What was one of the other? I'm thinking I'm missing one of the questions.
So expected payback in terms of finding leaks preemptively, and how many times? Yeah, you answered how it failed. So I think you've answered.
So yeah, I'll go one thing. When we're pre-planning this project. I think the DOE's anticipated trap failures 20%. We settled on, when we were figuring payback, we figured a little more at 15%. Currently, we're not into the heating season yet, so a good majority of our traps are offline. We're seeing 4 to 5% trap failure rate right now. We expect that to go up, when the heating season comes on. But we were a little more conservative with that 15% to decide payback if it was worth doing the project or not.
Makes sense. Okay, thank you. The next question is for Kit and Robert. What type of sensors and what cloud system did you use for the analytics and control part of the overall setup?
We've used just a typical loggers and also flow sensors on the compressors. As far as the cloud system, it's just your internal cloud system that would be able to store all the data and feed that into the system. Robert, do you have something to add to it?
Yeah, we have to be careful about specifics at this point in time, but they're just standard key and sensors, key and flow meters, key and pressure sensors, but they do feed back into a proprietary learning model.
Cool. Looks like the next question is for James. With reference to the regression model and HVAC system, you referred to feedback to vendors. Can you share what vendors and sort of feedback and action based on feedback was taking place?
Oh, okay. So for that, we were able to basically just share them some of the data from our sensors and from our actual model. Am I coming through?
Yep, you are.
Oh, okay, great. And then that was what we were able to share with them, and that kind of helped them see if we were seeing the savings that was initially promised. I don't know if I can have enough information to share like the exact vendor for it.
Okay.
But that really helped them and encouraged them to find different ways and to figure out like which individual units and things like that they can really deep dive into, see which ones are we not seeing the savings for versus just looking at an overall utility bill like year to year. They wouldn't really have that visibility.
Yeah, excellent. Thank you. Thank you. Let's see the next question to Kit. How do you balance the compressor load between the machines that use high pressure and the machines that use low pressure?
I think this one I will move it to Robert. He would answer more of the technical questions.
Okay.
So that one's pretty simple. Our high pressure machines do a much different job and a much different part of our process than our low pressure side does. So there's really not any balance between them. It'd be more between the multiple systems that are controlling that particular pressure.
Okay, that makes sense. Okay. See, the next one I think is going back to the 3M team. What is the simple payback period for the whole steam trap monitoring system, if you can share that?
Yeah, when we typically, 3M is at a 3-year payback plan. We worked with Energy as a service provider through the corporate team to look at some bigger scaled projects that didn't meet necessarily that 3-year payback, longer term payback, but was still long term, would drive us towards some of the goals Tan May covered. So I believe this is in that 7 to 8 year payback range.
Okay, cool. The as a service model is always interesting to me, so I'm glad to see it's working out for you. The next one is the projects you present are very good. To validate all data, you need a lot of meters, investment, and hard work. In your experience, which would be the best way to start with this? And I'm not sure who this is directed towards, I suppose it's kind of open to both teams here. So whoever would like to take this on first.
Yeah, I can share some light on that. I would say first, always try to justify the as well, not just from the emissions and cost perspective, but also from a multiple benefits perspective. There might be some non-finance benefits of adding more metering side as well. And this is not directed to the stick, but just overall for any energy efficiency projects. Like, what are different ways we can identify more opportunities, right? And once we get some funding to install at least some of the metering as solutions, right, that would basically lead us to identify more projects on the overall justification.
Okay. Anybody else want to weigh in? Okay.
Well, yeah, in Hutchinson, we talked, right, compressed airs, obviously we put electrical and flow measurements on there to get our standard, but then we also went to the production level machine and put metering, right, to generate a baseline. And if they see that baseline shift, right, that they're gonna leak check their individual production machines. So we're putting a little more ownership on the production area maintenance group to manage that and have that automated, so they do get an alarm to realize that they need a response.
Okay. And I think this will be our last. Oh, somebody gonna say something
Yeah,
else?
just something to add on to that. For us, for this specific project, we started looking into the direct impacts of it. Let's say for our example, where manufacturing facility, like the direct impact of it would be your production count, or what you would be looking for in your historical data as well. So these are the things that we would start looking into it first to see if it's getting a good trend or a downward trend as well, to validate the savings further on.
So, thank you. Well, thank you for answering these questions. It looks like we're coming up to the top of the hour, so I'm going to start wrapping things up. Thank you to everyone for your questions and to our panelists for their insightful responses. This webinar is a part of the Better Buildings 2024 Fall Webinars lineup. As you can see, we have a great collection of presentations every Tuesday through the end of the year. Visit the Better Buildings Solution Center to learn more and to register for future webinars. We hope you'll join us on Tuesday, December 3rd for our next webinar titled A Smashing Success, Sustainable Management of Demolition Debris. Join this webinar to learn practical strategies for source reduction, salvaging, and reusing construction and demolition materials to support sustainable construction practices and minimize environmental impacts. I'd also like to remind you that we are pleased to announce the dates for the 2025 Better Buildings, Better Plants Summit. I suspect many of you are familiar with this event. We have them every year. The summit will be in the heart of Washington, D.C. from April 30th through May 2nd. In addition to engaging in interactive sessions, attendees can look forward to plenty of opportunities to network with their fellow industry peers and experts. Subscribe to the summit's email list on the Solution Center to hear the latest on registration, sessions, and more. And finally, to close out, with that, I'd like to thank our panelists very much for taking the time to be with us today. Feel free to contact our presenters directly with additional questions, or if we couldn't get to your question during the Q&A period. I encourage you to follow the Better Buildings Initiative on LinkedIn and X for all the latest news. You can find our handles by the respective icons on the left half of the slide. You'll receive an email notice when today's recording, slides, and transcript are available on the Better Buildings Solution Center. And thank you again to our presenters and to everybody for attending and for your questions. And this now concludes this webinar. Thank you and have a wonderful rest of your day.